Thanks. Thanks, Clay. And yeah, thanks for everyone for joining. And I'm pretty excited about this topic today. As Petra Skills as a whole, as we start to navigate more and more uses of virtual reality, we've seen a lot of different types of systems. I can cover and I'll go through, there's different levels of virtual reality, what I might consider high end, or maybe things that you could either call lower end or maybe more practical in another way. But I think it's a really kind of appropriate topic right now, because both internally here at Petra Skills, but also with a lot of the education clients I speak with, about a lot of the industry clients, it seems like it's a challenge that a lot of people are tackling right now. There's a lot of investment going into virtual reality. So I want to present a certain view, at least internally here, how we're approaching it, how we kind of see best cases from some of our clients, how they're approaching what type of training to do with this new tool. And for me, it's a pretty exciting topic. So yeah, I want to thank you again for joining. And the objectives for the webinar, I can jump into this. And just to give you an idea, what I have planned is anywhere 30 to 45 minutes. So I'll certainly leave plenty of time for questions at the back end. And I appreciate Clay mentioning that putting those in the chat would be great. But as far as objectives of what I'll cover in that 30 to 45-minute period is, I like to focus on more of the capabilities of the team troubleshooting that can be done with virtual reality. So I think it's such a powerful tool for some of this team troubleshooting, both at the education level as well as the industry level. I'm actually going to ask a poll here in a second about some demographics about who's joining. And depending on that, I'll focus more on using more education examples or perhaps industry, but I really think it's appropriate for both. What I will do as well is I found, especially working closely, and I'll introduce myself more formally in a slide here to give some of my background, but I work with quite a number of education clients, and I believe these virtual reality tools are really, it's a great opportunity to check off or really reinforce some of the educational objectives that are set forth by some of the popular bodies, whether it's at the engineering level or the process technology level. And I'll talk about where I've seen some best case uses of that. And then I want to talk about, as more training is done just in a virtual format itself, an online format, how we can leverage these tools and kind of what our current approach is here. And really what I want to focus on is just that, leveraging the tool. So I'll talk about a certain virtual reality system that I'm used to, but any of the topics I go through here and our approach for the training could be for a virtual reality tool that you're already using at your site, or maybe it's some different ones that you're evaluating. So I'll use a common example throughout the webinar just because it's the one I have access to. But really what I'm going to try to focus on is how you can get the most out of the system you have, or perhaps just present a different view for you on some different areas of operator training that you can focus on with that tool. As well as always, I always enjoy, because I work both in the industry and education sectors, and I always just like to throw that as an objective anytime we have a chance to meet, whether it's advisory board meetings or conferences. I know what makes things work at the education level is input from industry. So I always like to say, if there's ever an opportunity to network or anything like that between education and industry, I always think that's an important objective. So I'll give some background on myself and our group inside Petra Skills, no more than 5 minutes, but just to give you an idea of where I've seen some of this virtual reality training, how I'm currently applying it personally, as well as how Petra Skills and our member companies are. Then what I want to do is talk about what I've seen. So one of the things I'm doing inside Petra Skills is I'm looking at a lot of different types of virtual reality training, and I'm trying to summarize what are the best case uses, where are you getting the most, bang for your buck, so to say. So after being involved with this for a few months now, I'll just give kind of my summary on where I see the current industry and education applications of this. And then what I want to do is in more of a demonstration style, more of a workshop style, where I'll show some software and show some specific exercises. I want to talk about where I think there's room to grow. And I really want to focus on two things, and it's utilizing these virtual tools for troubleshooting, as well as utilizing them for team-based training. So when I give kind of current status, there's a lot of great current applications of knowing where all the equipment in your plant is, to be able to see internals of equipment, and that's all great stuff. I just think currently what I'm seeing is it's a bit under leveraged in the sense this is a great tool you may already own that I think you could really develop some really great troubleshooting exercises for. And I'll give some examples of that. After that, I'll do some, I'll pause. I'll leave at least 15 minutes for Q&A, and I'm looking forward to that. So what I'm going to do right now is I'm going to open a poll. If you haven't taken a training class or you haven't used polling in WebEx before, what I'm going to do is I'm just going to click open poll right now. And now on your screen, you should see a little window. It's got 2 multiple choice questions there. Just be aware that's your window. It's your window to click and answer and eventually exit out of. So if you could go ahead, I'm just asking 2 questions. I just want to see if more of the folks here are represented from industry or education. And then the second question is, I'm interested to see if you have any experience conducting any process training at either level with virtual reality tools. I think if I asked that question 3 years ago, the answers would have been maybe 10, 15% of people, depending on the company you work for. And now, well, we'll see soon. Now it looks to be slightly higher. So I'll let that poll run for another few minutes. And I appreciate everyone answering. Just because I conduct a lot of training in WebEx, I'm always so particular. There is a submit button that you'll have to click for me to see the answers come through. But I want to share the results back with you so you can kind of see the audience we have here today. Okay, great. So we have 21 responses or so, so not to rush you, but I'm going to go ahead and close that and share the results back with you. That way we just kind of know our population. When we get to the Q&A, I'll have a better idea where to really focus on for specific applications and things like this. So the poll is closing and will be closed in 5 seconds. And when I share it back, you'll just get a little summation of it, and I'll talk about it as well. Okay. So just a reminder, you just got another window now, and now it just has the results in there. And again, that's yours to exit out eventually when you want to. I'm not controlling that as the host. But it looks like we have a mostly industry in here. So 17 of 21 responses are at the industry level, and the remaining 4 or 5% or so are at education. And then as far as experience using these tools, we have 5 of the 21 said yes and 16 no. Okay, that's good to know. So I'd be really excited on the back end of this, the 5 there, not to put you on the spot, that have used this. I'd be really interested to hear maybe some best practices, where you found success, where you found challenges. And as I go through, give my summation, I'd be just as happy to hear kind of how people out there in the real world are using this and what you've seen so far. Because I don't think this is going away. I think the tools are going to become cheaper. And I think it's going to be even something that's involved more and more in training departments. So to jump into things, just a quick little background on me. So the reason I show this mainly is just so you kind of know where my point of view is coming from. So my background is chemical engineering. I graduated from Rutgers in 2014. That's a University of New Jersey here in the United States. What I've done since that time is about half the year, I go on site and I teach troubleshooting courses for console and field operators. This is mainly in the downstream and midstream sectors. And what we do is we come in for 2 days, we bring process software, and we teach troubleshooting skills. So it may be courses on distillation or furnaces or compressors, but the key thing across any course I've ever taught is it's really troubleshooting. And why that's appropriate is 6 years ago, the troubleshooting was all on the DCS simulation. As we started to add more virtual reality, now it's more VR, and we've used some different partners here and there. And now as we evolve, we're doing more field operator training, and now we're really kind of getting more into this VR training. So I have had an opportunity to kind of live this and see what's worked and see what operators find unrealistic. And so I can certainly speak on that experience a bit. And in addition to training operators on site at mainly refinery, petrochemical, or gas processing, I also work closely with our education clients. And the 2 main sectors of education are both the process technology. So that is a degree here in the United States, and I know they're all over the world, but they may be called something else. But in the US, that's a 2-year degree, and that's training future plant operators or technicians. Some in Canada, sometimes it's called chemical engineering technology, and sometimes it's just called chemical engineering when you get overseas more. But in addition to those future operators, I also work at the education level with chemical engineering universities, which probably doesn't need as much of a definition. One other fun thing that we do, and I'll touch on this at the very end when we talk about interactive exercises. In 2019, I helped co-found what we call Chemi Sports. And this is something we've been doing for the last few years. We get universities around the world. We have a competition on a simulator that uses both DCS and virtual reality at the education level for chemical engineers. And this past year, we had 34 teams compete. We actually had a team from Sri Lanka win. The year previous, it was a team from Nigeria. And the year before that, it was a Louisiana team. So schools like Texas A&M, University of Virginia, and then kind of around the world. So I'll talk about that Chemi Sports experience a bit when I talk about how we can build some of this more interactive exercises. But just to round out the background on our group, so what we focus on is operator training using 3 parts. And what I'll focus more on is this actual VR part. So I had historically, my background, I did console operator training. We worked with a DCS. Well, more and more the last 3 to 4 years, we've been using different virtual reality systems. Again, I actually produced the DCS. So I almost look at it more as a client when I look at virtual reality, because this is not things that I produce. So I've worked with different systems, and I think I have more maybe perhaps your standpoint when evaluating these systems, where I actually produce the DCS for the simulator. In addition to that, we have a methodology. I won't go in much detail about that other than just give us a framework to talk about what types of training we could do. So again, I'll talk about our simulator, our methodology, but you'll see very quickly, very similar to probably whatever simulation you're using, if any. And the methodology, I'm sure, is very similar to the type of framework you have for your operator training. In fact, the 5 steps of process operator training I'm going to talk about are identification. And what I'm going to do is relate kind of where VR is at these 5 steps. So identification is when you first have an operator coming on board, and this is, okay, where's all the equipment? What's its purpose? How do we relate a PNID, a console perhaps, in the actual field? Normal operations, that's, okay, how do we expect things to respond? Maybe it's how do we follow a standard procedure for swapping pods. Startup and shutdown, self-explanatory. And then, of course, troubleshooting is the big one. And then we also group in, not everyone includes this in kind of their overall methodology, but we group in this what we call operating strategies or optimization, kind of what are the limits of our different pieces of equipment, how do we maintain product quality, different types of this, and it starts to get system dependent. But what I'm going to do in just a moment here when I talk about the current status, I'm going to talk about how VR, I see it, currently being very well utilized in these first 3 steps. So generally speaking, normal operations, and how, where our plan is, how we identify things, and where I think the current gap may be is mainly this troubleshooting. So I give this framework to kind of just give us a point to talk about different types of training with these tools. And then just the last slide I'll give on our general methodology, and I do think this is important, and it applies to our virtual training as well. When we approach operator training, our main objective in any content we develop, deliver, or advise potential clients on is really teaching operators how to think. And I like to show this slide here, which is kind of looking at the industry. And we can say, I'll use a downstream example, but I think it's analogous to pretty much across chemical process industries. The actual technologies, for the most part, have gotten to a certain point where, distillation is distillation, catalytic cracking is catalytic cracking. And the actual advancements now, expansion projects are mainly to deal with environmental concerns and things like this. The actual processes aren't changing all that much. What's truly changing is the advanced process control. And it seems that there really is no end in sight for this. And that's a good thing, right? It makes our plants more reliable, safer, more efficient. But as we get into this world of advanced process control, really what we see working with these operators day to day is they can feel separated from the process. So again, they might be doing less day-to-day operator-initiated board moves, this green line. And even more importantly, what we're seeing is their time to actually develop this operations mindset, which I'll define in just a moment, is also decreasing. So when your group has an opportunity to do offline training, which is what we may use virtual reality for, we think it's really important to not only use these tools to do things like, here's where this piece of equipment is in the plant, here's how you follow the standard procedure, but leverage these tools to start getting operators to think about why they're doing what they're doing. And I really believe there's an opportunity here for what we call operator upskilling, but your site might call it something else. This is the mindset of the operator. We believe virtual reality could really be utilized for this type of skill set. So just to define those a bit further, so mechanics, what are we talking about? Equal are important. So we're not saying you only need to focus on the mindset. Both of these are important. But these are things like ability to work within operating procedures. You give a field operator, here is a procedure for how you are going to switch from pump A to pump B, and they can complete that procedure as it's written. They can stay within the operations limits. But when we look at mindset, what we see here is this is a higher level skill now. This is you have the ability to analyze reasons for events and upsets. So you're swinging pump A to B, and now something perhaps doesn't go wrong or it deviates from the procedure a bit? Are you just blatantly following step 1, 2, 3, 4 with your head down? Or do you have an expectation of results as you're moving? Do you have an ability to prioritize and deal with events and their causes, and to be able to gather extra information to kind of determine magnitudes of upsets? And we believe if you apply both of these, and if you approach the training with these tools for the mindset as well, operators can stay proactive. They're developing both this mechanic and mindset skill. And what we, not joke, but what we tell operators is, you are running the plant. That's where you want to be. If you're simply reactive, if you're just applying exactly what's provided with you, you could be kind of caught behind the plant and it's a constant struggle. So we're trying to promote skills that really is about how operators think. And I think there's a great opportunity to do this with some of the virtual training out there. So that's just a bit of background. Here's my summation. I'll really just talk about one slide here, about what I see current status. And I see there's some really, really cool training out there. And what I think is the current utilization of virtual reality, and this isn't for every operating company in the world, but what I see is the VR tools do a very good job at kind of these first 3 steps we've defined. So identification, I know there's some vendors out there and some companies that can do things, and you might be familiar, where they're taking 3D cameras of your site, they're tagging every piece of equipment, and then you can imagine the operator can go in with the different Oculus glasses, and they can go in and you can give them a task, go find valve, FCV 103. And the operator can relate a PNID, they can go there and they can physically see exactly what that valve is. That's extremely powerful, and that is a great application for virtual reality. What we'll see then as well is things that are procedural or startup and shutdown, and I'll group those together. These are the example I use kind of, okay, we're going to work on this section of the plant startup. And what we're going to say is, we want you to go over, turn this valve X amount. We want you to block this in. We want you to go ahead and start P120B motor. And again, it's very procedural. It's very valuable because now, of course, when the operator goes in the field, they've seen this equipment before. You're limiting the amount of error for things like identifying an incorrect piece of equipment. And I believe where we currently are is the value that operating companies are getting from these 3 steps, we found have been enough to justify the tool itself. And I'm not arguing against that. I believe this is powerful, that you could take someone offline, they could see the plant just as it is, and they can work through what I'm calling these first 3 steps. My contention, as I go through this, is if you've already made the investment or you're looking to make an investment in a large virtual reality simulator, I believe there's quite a bit of meat here where you can develop team-based, meaningful exercises about the process, mainly for this troubleshooting area. So right now, I see a lot of training that's done to rote memorization. Things like being able to see cutaways of equipment, that's another huge, you're trying to explain to a new operator what the inside distillation column looks like. You used to pull up a YouTube video, that still works, but now you can actually go ahead and actually be in that environment and see the downcomer and things like this as you're going through. So to summarize, currently what I see with virtual reality is a very strong application for those that are using it that could certainly justify the cost of it for identification, their normal operations, and things like startup and shutdown, very procedural areas. What I want to do now is actually go ahead and more calmly kind of walk through where we think you can apply some of these tools for things like troubleshooting and upset. And what I'll do is I'll actually go ahead and just launch one version. Again, the purpose of this workshop is not to just show one certain process simulator. I truly believe as I go through this and launch this that you could apply these different techniques to any simulator you might currently be using. It's just the one that I can currently use. So what I'm going to do is I'm going to go ahead and I have just a simple absorber and stripper process here. This I'll call the DCS, Distributed Control System, and this is what I'm currently calling our VR outside operator. Just a couple notes when I look at this. Right now, I am running both of these windows from the same PC. Right now, I am not using any sort of, as you can see looking at my face, I'm not using any sort of virtual reality goggles. I'm not using any sort of, this is all standard PC-based. the same types of troubleshooting exercises that I'm going to say I think could be even enhanced. Number one, which is the big one, using the same system on 2 different machines. That way you have team training, right? So 2 different either students or operators in 2 different locations working on the same dynamic process. So I'm not showing that right now because I can show 1 computer, but I think that's a big benefit and something you should keep in mind. And then the other one is as we start to get to more advanced technologies. So this right here, and I'll make this one full screen here, or this is good. This is our virtual plant, right? We can see our absorber and there's our stripper, and we can walk around and take a 360 view. And in the previous slide, when we talked about identification, we could come look inside the absorber to see what it looks like. We could go ahead and do a procedure where we start up pumps, and we could actually go ahead and follow a startup procedure. Because I have 45 minutes of your time, I'm not going to go through those. I'm going to go through what I think is more interesting with the troubleshooting. But just to give you an example, you can imagine a situation as I come through the system where you're conducting team startup, and that would look something like this. I'll just pull up what we do. You can imagine a situation where I'll just go to a random part in this startup procedure. This is good. Where you're going to begin certain circulation in the process. And the key thing I'm trying to show here is there's functions for the outside operator using the VR. So they're opening some sort of valving. They can go in the field, actually find that valving, begin to open it. And then the console operator at the same time is working things from the DCS. And I see this as a strong application from most of the VR that's out there right now. So right here, we're already attacking the team training, which of course, startup is a team exercise. So I'm not going to focus on this so much because I think people are doing a good job with it already. What I want to focus on, and I'll actually slowly use this system, so I'll start to introduce it and walk around to a specific piece of equipment when we do some of this troubleshooting, is I want to go ahead and just show you maybe 2 exercises. And I want to show you 2 exercises, but the focus I'm going to put here regarding troubleshooting is how do you incorporate that virtual piece? Sometimes what I'll see, and I'm not saying everyone does this, but sometimes I'll see an investment in virtual reality, and it's at the education level, it's a very neat thing to attract students to the program. Students go in for a lesson, they're able to walk around and say, oh, wow, that's what a distillation column looks like. And that is powerful. But after that initial kind of wow factor, it's just, or maybe they put the goggles on and now they're looking at a pump system. But after that initial wow, we don't really see, okay, are we still conducting training on? Or at the plant, perhaps, your outside operators now during their onboarding program, you can more efficiently identify the process to them, convey where equipment is. But again, do you still use that tool as you're going through more of your developmental training? So what I'm going to focus on is, I know a lot of people use process simulators, so just maybe more the DCS to conduct troubleshooting and things like this. Let's talk about how you can meaningfully utilize the VR there as well. So just to use one example for this, to start, I'm just going to show this is just one of our troubleshooting styles of exercises, and I could talk for quite a bit on this, but instead I'll focus how we use the outside operator. So this is something we'll go through the troubleshooting course. We call it, it's a troubleshooting methodology. We call it Think Equipped. And the idea is the equipped is an acronym. And if I go to the next slide, you can see it in a fishbone diagram. And what we do with console and field operators is we'll put in short little upsets into the simulator and say, okay, don't worry about fixing the issue right now. We want to practice the skill of troubleshooting. So what we want you to do is actually go through these specific categories, and I'll show you what the worksheet looks like in a second. We want you to go through, use equipment, utilities, process, etc. And we just want you to identify 3 to 5 to 7 potential bad actors. So what are the potential reasons for this failure you're seeing? And instead of just approaching it where the operator comes on the simulator, something breaks and they just have to scramble to try to fix it, we try to break troubleshooting into its parts. Or we say, don't worry about fixing anything right now. Let's just practice that skill of developing a list of potential failures. And then, of course, we'll eventually get to the corrective steps and then identifying and putting it all together. But I think this is a great style of exercise to start working VR in. And it's something I've done in the last couple of years here. So I'm going to go through a sample exercise, but I do want to show the worksheet. And then what I'm really going to highlight is where we can use the outside operator. So to give you some of our evolution on how I've done this, because I think by talking about how I've integrated VR, it'll give you an idea of how you can. Previously, what we would do is we'd put a failure in the system. I'll show one in a second. And we just had these steps 1, 2, and 4. So I'll try to make that clear here in a second, where the operator, the trainee, the student goes in and writes down a few observations about what they see changing in the system. So in our case, we're going to look at an erratic flow on one of the feeds. Then what we'd say is, okay, go ahead and use these categories. And what we want you to do is come up with 3 to 5 potential suspects. And I'll fill one of these out dynamically so it'll start to make more sense. And then eventually they have an opportunity to go in and rule out what, they eventually previously went right to step 4, which was previously called 3, and they said, hey, I think it's a coupling failure on this pump because X, Y, Z. What we've added now that we do the VR is we said, okay, who would you contact to start to begin to rule in or rule out these potential causes? And we talk about who would you contact, your outside operator, maybe you have a separate operator running utilities, maybe it's upstream, downstream. And now what we do is, as operators fill this out, we tell them, anytime you say outside operator, we want you, and now they're doing this in teams, right? It used to be solo, now it's in teams, and now we have someone on the DCS and outside. Well, it starts with a console person, and then we want them to go to the outside operator and have them then start utilizing the virtual reality and signaling back about, okay, you said it, well, I'll show an example. So basically with all of our troubleshooting exercises, what we try to do, and I would suggest the current troubleshooting training you do, I know a lot of you didn't say you have VR right now, but as you consider starting to add some, just try to take your current troubleshooting methodology and say, where can I start to utilize this tool more? You know, where can I start using the VR more? So this is one example of how we did it, and I can just show perhaps an exercise would be better than just a bunch of slides, and I'll show what I took an example from an actual class and some of the feedback we got. But the way the training would do this is they would load in an exercise. So I'll call it think equip number 1. They'd go through quite a number of these, and I'm going to turn off my alarms. Oh, good, already off. And the point of this is that very quickly something begins to fail. And you all have looked at the system maybe on my screen for a total of 30 seconds now. So of course, you know, I don't really have time to walk through it, but you can see there's an alarm here, right? You can see that currently it looks like there's an alarm, it looks like a feed flow. And if I were to move forward on the graphic, we can see a little more clearly here. This is our lean amine and absorber. So this is basically like a amine gas treating unit. We're bringing in a lean amine solution here, bringing in sour gas, and the overall goal is to go ahead and absorb most of the H2S or CO2 from the sour gas. And then of course we have a stripper on the back end to clean it up. But without going too in depth in that, where we'd start this exercise is the console operator would start to identify what he or she sees. So the idea here is they'd be filling out a written worksheet. I have an answer key, but I can kind of show it dynamically. They go, you know, lean amine solution is oscillating. Normally I would ask for the audience to answer these types of things, but confirmation confirmed by oscillating downstream variables. What do I mean by that? Very quickly, this seems to be oscillating, and then let's just pick any old variable, temperature. There also seems to be just some disturbance here, right? So, okay, we truly believe that that flow begins to oscillate. Now what we do in 2 parts, we say, okay, the console operator, take out your PNID. What is the different equipment that you would like to begin thinking could be a bad actor here? And what we'll see, I'll just pull up results from a class we've had before. Yeah. What we'll see is they'll rather quickly talk about it, and the point of this isn't the tricky there. But experienced console operators or people that are getting it quickly will be able to fill this out rather quickly. And they'll talk about, well, perhaps it could be the control valve. There's a pump upstream, perhaps that's cavitating. There's a filter system, filter clogged. And we start to, here's the key thing. We say, okay, who are you going to contact? Well, the outside operator. In the past for this exercise, there was no outside operator. It was just, okay, well, we'll contact him or her, and then, you know, and then we'll keep moving along here. Maybe it's an instrument error issue. Maybe there's light ends in your feedstock causing that pump to cavitate. Maybe you have low upstream supply from T100, right? So let's just focus on that one, and then I can show you the next one. So who would you contact? Outside operator is going to be in a lot of these categories. It's going to be the outside operator. Well, now what you have, we'll do it over radios. We'll try to get people in a different room. But okay, we've gone through 8 minutes. The console operators identified things. While they're doing this, they are now calling the outside operator who's on his or her simulator with the VR, and let's just focus on maybe we think this is oscillating because our pump here, P100, is cavitating. And why is that? Maybe we have low supply in T100. We see Li100 here. So we get from the board an indication that the level, it's not low, but it gives us a good opportunity to say, okay, let's start checking variables. If some of you people in the webinar today are more operations focused, you're probably going, that's not the most realistic thing. Probably other stuff you want to troubleshoot. So the outside operator, here's that T100. Again, we've gone through all the identification exercise, so they're familiar with the system. But now imagine a communication system where they can both check a site gauge and eventually go, okay, no, the levels, you know, it matches up with what you see on the console. Okay, check it off. Let's keep working through our list, right? So eventually what they might get to is, okay, we might want to check the pump status, so we could go check the amps on the pumps and different things like this. But what I'll do instead is just jump, let's go check the control valve itself. So I'm just going to parachute in because it'll be faster for the demo. They'd be walking around. So what we're looking at now is our filter. And here's our control valve. So now what the outside operator can do is actually go ahead and look at the control valve. And they can come in and they can see that the valve itself is moving up and down, as well as the air to the valve. So the outside operator can start relaying that information. If I go this long for a demo in a class, one of the operators is screaming at me, just put the valve in manual already, right? Because they start to deduce what it is. But what I'm trying to show here is it gives us an opportunity where we can put in different instrumentation, both on a DCS as well as a field, so you can start to build this team troubleshooting. And I work with the same pairs throughout. So they're going through and now they're saying, okay, check this piece of equipment. And where we really want to get it to, and where I think it's really powerful, is when the field operator starts contributing information the console operator didn't ask for. And I think that's a lot of the training we're getting to, is if you can have your field operator using VR start to see more of this troubleshooting process, they may start offering information that the console operator is not asking for that might help get to a solution faster. Eventually, for corrective steps, if it was an issue with the control valve that couldn't be fixed from the board, the operator can come in and you can kind of see a block valve bypass scheme. Then you could actually follow a procedure that's covered where, again, just like the startup, now we have a procedure where we're going to block in the control valve, we're going to work through the bypass and get the unit back online. But when we go through this, really what we're trying to do, and the point I try to show this, and again, it's not just any tool you're using. Whatever previous troubleshooting, if you were doing any, whether it's pen and paper, or whether maybe perhaps it was on just a simulator like this, just start adding in, make it a team training. Start adding in different tasks for the outside operator to use the virtual reality, and you'll start to see you'll get more and more out of this tool. So of course, we'll go through many like this, and they'll eventually go through, they could place a manual and stabilize it. But this Think Equipped, we've just found that this one has lended itself to the VR quite a bit, because it's an exercise really about gathering information. It's about weighing potential failures, what's the probability, and really by being able to go and have 2 points for information, have that instrumentation duplication, so to say, in the console and field, we found that this has helped really kind of build that team training. And feel free to use this, you know, any of this stuff, feel free to just apply it back to yours if you think any of this is catchy or something you might be able to apply back to any system you're training on. And then just because, yeah, with time, I'll just show one more perhaps, and then I'll certainly be on time here. But what's another way that we try to use this virtual reality in operator or at the education level, of course, as well? So again, I could talk about our methodology for quite a bit. Instead, I'll just try to quickly explain this because I want to focus more on how we've modified it to use virtual reality. So here's just another type of troubleshooting. Again, this one we tell the team the failure. So we tell the failure, okay, we're going to look at a system where you're going to lose instrument air to, I know those numbers don't mean anything to you, that's our stripping steam flow controller. So I'll use the same absorber stripper section. And again, you can think of any failure you want to put here. Before, when we were just doing console training, just with the DCS, we would tell the console operator, okay, this is almost like a hazard analysis exercise. What are the steps you're going to do to confirm the issue? How are you going to mitigate it? So how can you buy yourself some time before you get to the eventual correction, if there is one, outside of a safe shutdown? And how will you eventually correct it? Well, this one, I'll be quite honest, was rather simple to apply to the virtual reality. We just said, okay, what is the outside operator? How are they going to confirm the failure from the field? Applying the virtual reality actually becomes simple because it's closer to real life. So if you've just used the DCS simulation before, it's like all of a sudden you have this extra tool where now you can start to apply a lot more a level of realism. Where, okay, from the field, how are you going to confirm? How are you going to mitigate, correct? And then, of course, we go for safety concerns and we get to an eventual correction step here. But just to actually show some of this dynamicness, the teams would fill this out and they'd make their predictions about what they think is going to happen. But just to kind of show after we had this discussion, which isn't my point of focus here, I can show they'll actually then go apply a fix. Again, working in teams, working with both parts of the plant. So the way we'd run this is they'd come in and load in an exercise. So loss of air to FC301, I'll go to that one in a second here. I'm just going to skip ahead to our stripping section. So this is our control valve, just putting steam down to the reboiler. And what's going to happen, I think at the 15-second mark, if not, I'll force it to go in, is we're going to lose air to this controller. There we go. Okay. So now what we say is, okay, again, it starts with the console operator. This is if you're doing team training. If people want to know, I can talk about how we do it just with just outside operators or just console operators. But if we're doing team training, it starts with the console. Very quickly, they realize something's wrong. And now it's, okay, I need you to go check out what's happening over by the stripping steam. So the field operator is familiar with all this is. I'm just going to dive in again because I don't want to spend time walking around the plant. There we go. Okay. Here is the flow gauge associated with my stripping steam. And I can see it truly is 0. So we can rule out that that's a faulty reading from the console. Now what we could do is, again, when we first see this, it doesn't shout out that we lost air to the valve. We know we don't have flow, but we could be thinking it's loss of supply. Maybe the boiler's tripped out. Maybe it's the physical valve failed shut. Maybe it's a bad indicator, like I said. And from the console, if you're currently using this, you can see, well, the output signal from the controller to the valve is 100%. The PV is 0. I could try putting in manual and changing this. And I'm not getting any flow. So I'm a bit concerned because this green emulation here is just from the actual controller output. So what I want to do is ask my outside operator to go look at the valve. And then while from the console, from the console, it looks like the valve's open. From the field, the actual valve position, we could see it's 0 here. And we can see we've lost any sort of air coming to the control valve. So it's in its fail-safe position, or in this case, closed. So this helps both with the troubleshooting. It allows us opportunity to use to look at it and start to analyze the system. But then, of course, I'll just go quickly here, but it allows us a chance where we can actually go ahead and block out that control valve. Let's go over here so I get both block valves. Yeah, good enough. And again, following procedure, it would be faster or slower than this. But eventually now what you have is, imagine a console operator that's communicating to the field operator about starting to open this bypass, if we can keep the system online. So the outside operator can come in, can manipulate valves. Again, I'm doing a PC base. We're clicking things. You might have more advanced technologies where you can actually turn your hands, right? I've seen some cool stuff like that. Same general functionality. And they can come in and open this, and of course, they'd work together as a team. They'd see they reestablish flow. Console operator will probably take the controller, put it in manual, and just shut it, just so they're clear that they're working through the bypass. And then we could talk about, eventually how we fix that and who do we have to call and things like that. But again, it's this idea of working between teams. It's the idea of, I bought this tool, I'm looking to buy this tool, and it's going to be used for BOT training, or it's going to be used for an expansion project, and we're going to be able to show everyone where all the equipment is. And our argument is, that's great. If that gets the project justified, awesome. If you still have access to the tool, if you apply some higher level troubleshooting concepts, some different techniques, you're going to be able to get a lot more out of the tool itself. And that's kind of just my view of just, in the last 6 months, and I know some companies are doing a phenomenal job. This isn't everyone. Some I know, for example, I read a paper from ExxonMobil. They do quite a bit of troubleshooting with their VR systems. It's really, really neat stuff. So it's not that, we're not the first ones to think of this. It's just that it doesn't always happen. And if you're starting to look at some of these VR tools, I think focusing on troubleshooting and not just startup following procedures could add quite a bit of value to your operators. Okay, so they go through it, and because I know we have some education clients in here, I just wanted to highlight one thing. So that's 2 styles, and I'll end here in 3 minutes. I work with quite a bit of education clients, and the whole idea of how do we tackle team training? How do we tackle soft skills? How do we tackle communication? And everyone can find coverage for it, right? They work in a group together on a project, or they work on a paper together and they give a presentation about their results in the lab. And I don't mean to demean that, but if you have a tool that is meant to mimic the teamwork that happens on site, then if you're doing this in your classroom, these are just, for those familiar, these are the North American Process Technology Alliance objectives for the troubleshooting course. And this is their overall troubleshooting methodology here, and these are getting to the objectives of what has to be done for a N.A.S.T.O university. Very similar to like ABET or the European one I'm not going to get right away, but everyone's got these standards. And right here, I just highlight very quickly, when you're mapping out what you're doing, how you're assessing, communication of problem, determining not both where it's needed, but communicating with team members. Well, now we are doing this actively. And we could cover it in different ways, but now we are covering it in the same way that they're doing in real life. Your industry sponsors, of course, are going to like it. And a lot of the instructors come from industry, so you already know this. So it just gives you an opportunity to kind of touch on that again. And then the last thing I do want to say, because this was geared initially towards more education, so I have just a little bit of education here. I mentioned that Chemi sports competition. This is something that's growing for us. We use, actually last year we used this system. We used the absorber and stripper, and we used the VR. And the idea with this is we have student teams go through, and they actually get a score. And you can see them competing here. This is from 2019. They go through, this is the team on the DCS, and they're working through a system. If I really zoom in, you'll see they're getting a score here out of 100 based on alarms, profitability. And we've seen such an uptick in this and excitement from the chemical engineering student level. They're practicing for weeks ahead. I mean, it's no lie. As much as I like to say, keep it realistic, do meaningful training. When I work with the operators, they don't want something that's like a video game. But at the education level, this VR, I'd be pulling the wool over my eyes if I said it's attractive to younger people. This type of training, we get more and more teams each year competing. It's been quite a fun project. And again, this last year, we were working teamwork at the level. We had a team from, this is the team from Sri Lanka that won in 2021. And I always just like to pitch this, so to say, in anything I do is it's free to compete. If you're someone who works closely with a chemical engineering program, please give them my information. We're trying to grow this. We're going to live stream it this year. And again, it combines the DCS, the virtual reality, the team training, and it gives some process knowledge at the engineering level. So that's just something that I always like to kind of talk about. So I know I only showed kind of 2 examples there, but I just want to give you an idea more of the overall our view of it. The final thoughts I'll give, and I like to end on this, and this is a case study from a woman named Barbara Holder at Boeing. And when you look at virtual reality or you look at simulator training, I think the airline industry is a great one to look at. And the reason for that is because they almost did the original simulator training. They do it at the highest level today, and there's quite a bit of data there. So this was a study, and the reason I show it is I'll get to the punchline, but anytime a pilot is going to encounter a new flight management system, so imagine autopilot, right? This is your advanced process control in the plant. Anytime that they're going to fly an aircraft where that's been modified or it's new, there's mandatory simulator training. And here in the United States, that's regulated by the FAA. So what they started doing was, let's say the control system changes a bit, you're flying a new type of aircraft, whatever it might be, you go through your week of training on that with simulated exercises. They polled those pilots and said, in the first 6 months of flying your aircraft, did you encounter a situation where you had difficulty performing particular tasks in the new FMS? So this is after the training. Did the pilots have a difficult time performing tasks using that advanced process control or flight management system? And the results are a bit staggering. A few times when they're in the air, they had difficulty. It's not really great to hear from someone that flies quite a bit. Only 25% said never. But I think what's more interesting here is they went through and Boeing did a whole study on this. Remember, these simulators they're using are multi-million dollars. They fly exactly like the plane. You know, the tool I happen to be showing is somewhat like the plant, right? But this isn't your exact plant. You could go get a VR that's your exact plant. But these simulators are the exact plane. And when they polled the trainees, the pilots, they said, what were your negative experiences? And the simulator inaccuracy, what they were using was only 2%. Where they found negative experiences were with the instructors, the course content, or the delivery of the course. So these are things like inappropriate assessment, unrealistic scenarios, SOPs violated by instructor intimidation, et cetera. You can see, and I'll send the slides, but to group them together, it just, when I saw this, it brings to light that you could spend $1, $2, $5 million on a tool. But our pitch, especially it's very aligned with what Petra's goes, just our company as a whole, is yes, the tools are important, but the way you actually deliver this, who's delivering it, what are the structures, what are the objectives, I think are always the most important point. So I just like to end that when you're looking at virtual reality training, and again, you can have a whole different discussion. We could have one about here's the different types, here's where these types are at a higher level, here's the cost benefit analysis. But I think my focus, what I want to talk about was, I think each company is going to start employing some virtual reality. And I would just like to say, as you begin doing that, just remember that the content, the delivery, and the instructors, from a training perspective, is, in my mind, just as important as the tool itself. So I appreciate you kind of just taking our look at this. This is something, you know, we don't have all the answers on. We're navigating this. I'd love to hear how some people have approached this, some challenges, some wins, but we're just trying to stay ahead of the curve here and kind of make sure meaningful training is done on these new exciting tools. So I appreciate everyone's time, and I don't know if there's questions in the chat or if you had any questions or wanted to talk about an experience you had with virtual reality. I'd be happy to do that. So thank you.
All right, thanks, Matt. So let's see, I have received a few questions here, so I'll start going through those, but we're doing well on time, so if anybody has additional questions, go ahead and type them in the chat, and we will cover those. So let's see, the first question I have here says, has your experience been that certain types of incidents or equipment work particularly well or poorly in a VR environment compared to a more, in quotes, old-fashioned static troubleshooting exercise?
Sure. No, that's a really good one. Take note that my experience is more on the downstream side of things. So where I've seen some of the best applications, I believe it was Shell had something really neat, was, and this wasn't with us or anything, was furnace training, specifically with the lighting off of furnaces, just because that process of starting fired heaters is very field operator intensive. There is quite a bit of equipment, there's quite a room for error, as well as just, of course, the human safety aspect of that. What I've seen anecdotally is if I see companies are making kind of that first investment into VR, I just personally have seen on more than one occasion, excuse me, that fired heaters have been a place to start. I also think it's kind of a smaller piece of equipment, so you don't have to make some huge investment, and I think there's a need because furnaces are ones that trip. So I hope that answers the question, but just if I had to think off one off the top of my head, because some folks just simulate the entire plant, but I've seen some pretty good success with fired heater virtual reality. And again, combining that console, the field, going through more of the procedural and being able to see, you know, here's what your flame type looks like. Oh, we have impingement or just whatever it might be. So things like that.
All right. Very good. Let's see. I got a couple different versions of this question, so I'll try to paraphrase a bit. But essentially asking, what's your suggestion as far as conducting this type of training with field folks, field operators, and console operators separately, together, a mix? What's been your experience there?
Sure. Yeah, and you know, the limiting factor here is always time and resources, right? So what I would say here, to use kind of my own words back, but if you have a new set of hires aboard field operators, so basic operator training, you're not probably going to bring console operators in there, right? So if you're using VR for identification, hey, here's what our process looks like. When you're in the field and the console operator asks you to do this, here's the valving you open, you can actually practice this physically. During that kind of identification or normal operation steps, I think that's where, if you had to have, you know, just siloed training, I think it's going to be most effective there. I know that you cannot always get these folks in the room together, but I think if you knew you had 2 days in the year where you could pull off shift A for some team training, I would focus on the troubleshooting, because that is a team event itself. So my answer to that, and I know it's like how I want to answer that, is have them together for all of the virtual reality training. But I know that's not always realistic, because you're getting people at different parts of their career and you just simply can't pull that many people off. So my answer there would be, if I had to split it up, some more of the identification, some more of the theory that you might use VR for, I would do that in siloed. And then for the troubleshooting, I would make the strongest efforts there to have the group, because we've just seen such good results from that in the heterogeneous classes we do as far as position.
All right. Next question here asks, how would a digital twin fit with the simulator and VR?
I think I know the term, but please correct me if I'm wrong. So my idea of digital twin is you either have a simulator or an actual process. And then so you have some sort of process or P&ID that's your process out in the field. And then the digital twin would basically be this part, except it looks identical to your plant. I'm not sure if there's a way to confirm that, if that's what was meant there. If not, I'll keep working off that assumption. And I'm sorry, Clay, do you mind repeating just the last part of that question, just because I got hung up on the term?
Sure, yeah. It just asks, how would a digital twin fit with the simulator and VR?
Okay. So I don't do much training on, like, I would call that a custom simulator, the digital twin. And it's not because I don't think they're valuable tools. I just haven't had that experience. If it's anything like the custom OTSs, you know, the ones you will get from your controls providers and things like that, I would just be wary of making the investment of that digital twin that you internally are going to support that. Because if it's truly a digital twin, and I really hope I'm not getting the phrase wrong, but if it's truly a digital twin, as you make expansions to your site, as you change different control schemes, as you do this, are you upkeeping the digital twin at the same time? So that truly is a living, breathing replication of your plant. There's some teams that do this. There's some operating companies that are able to do this with their simulators, and they have great results. It's just that the company itself makes the decision, makes the investment. We are going to have a simulator team. So not to throw just names out there, but like I know they're kind of through, like BP has a simulator team, and they have OT specialists, and they upkeep their custom simulators, and I'm sure they are upkeeping their VR. So what I would say that is I do think, even though I'm not involved with that, I do think that's the highest level you can get with these. I would just put the one disclaimer that if the plant evolves and the tool stays the same, you're just left with a generic simulation at the end of the day. After year 2 or 3, it just costs 10 to 20 times as much. So anyway, that's my general thoughts on that. But I do think it's a fantastic tool if it's upkept, which some people do.
All right. Next question here asks or says, I'm operating a natural gas distribution network, and they would like to know if VR can be applied to it and any recommendation of software for that. And if this is one you want to follow up with after, that's fine, but any thoughts on that?
Yeah, so it's I certainly could follow up. It depends on quite a number of things, and this is kind of what Petroskills has asked me to do, is see who's out there, see who's best for different types of jobs. So I'd be happy to talk specifically and kind of talk about, are we talking about, I mean, I think natural gas distribution has the equipment and types of systems that would be well-founded for this. I think I'm just hesitant to kind of throw out a name and say, go talk to this company, just because I just like to hear kind of what scope are you looking for? Is it scenario-based, meaning I want to cover these 5 scenarios, or do you want something that's completely free-form so you wouldn't be able to go through everything? But no, that's a world I've lived in quite a bit the last 6 months. I'd be happy to give you a call, get some quick information from you, and I could just give you a couple recommended of our kind of like Petra Skills recommended providers that we hope to continue to have partnerships with. So yeah, I'm sorry. I just don't want to throw one name out there because I just would like a little more information about the project itself.
No, it makes sense. We can follow up afterwards. And then this is the last question I've got. So this is kind of last call for if anyone wants to sneak any questions in before we wrap up. It says, how do you approach evaluation or grading on a VR application like this?
Sure. Yeah, that's a good point. That's something that'll come up in education quite a bit. So what I'll see on systems, like for example, this system, so the system I use, it keeps a log of every action done both from the console over here as well as from the field. So as you can imagine, after a training exercise, what you could do is actually have both parties save. And then what you can do is actually go through and apply some sort of metrics to this. I believe some of the more advanced VR systems may even have like real-time feedback to trainees. And what I mean by that is if it's scenario-based and they're going through lockout, tagout, and if step A is done, that's a bad example. If step C is done before step B, it might like flash them a warning, you know, so that's kind of real time. And then the other one would be how I currently approach it, would be actually saving the exercises and then applying some sort of automatic grading to that. That could be deviation of set points, looking at sequence of steps, things like this. Quite honestly, for industry, I do a lot of instructor-led training. So outside of education, my training is instructor-led, so that's small class sizes, and we're just going through and giving feedback automatically. We're sitting down over the shoulder and doing things like that. But the tools, normally the limitation is not the grading, so there's some neat things out there. But it's certainly a consideration if you're looking at different potential VR partners. That is a consideration you want to have going in. How much evaluation do you plan on doing, and does the current vendor, are they able to do that? Thanks.
All right. Well, that wraps up the Q&A section. Thank you all for the input, for the questions. For those of you who chatted in with follow-up items, we'll get those to you. And then if anyone had a question or wanted to discuss further but didn't get the chance to in this short presentation, I'll be sending out the recording and these materials afterwards, along with our contact information for Matt. So feel free to give us a shout if you want to discuss this further. Matt, thanks very much for a great presentation.
Sure. Thanks, Clay. Appreciate it. Thanks, everyone.
All right, everyone, stay safe and enjoy the rest of your week. All right, thanks, Matt. I'm ending the recording right now.
Sounds good.
Appreciate it.
Yep.